Hello, my name is Bryan Chun with Hickok Cole Architects in Washington, D.C. I'm the Senior Project Architect for the International Spy Museum. So what's this architecture about? There's nothing like it in Washington, D.C. that looks like this. And if you look around, Washington, D.C. is many things, but very frequently it is concrete, it is rectilinear, and if you don't have a window mullion every 5 feet on center, you can't lease your damn building. We don't have anything like that here. The architecture to the Spy Museum building is inspired by spycraft and espionage. What do I mean? So the inverted trapezoid, that black form, we call that the black box. That's what houses the artifacts, the exhibits, and the main museum guest experience. That represents the aspects of spycraft that are hidden from our view, outside of our consciousness. The cracking, the hacking, the analysis, all the stuff that happens in the basement of the CIA. Offset from that, juxtaposed to that, is this lacy, bespoke, transparent curtain wall. We call that the veil. The veil represents the aspects of spycraft that are hidden in plain sight. So those two dudes on a park bench, maybe they're trading nuclear launch codes. That trash can over there, maybe it's a dead drop for sensitive military technology. That is the central design concept for the architecture of the Spy Museum building. You have the hidden and the hidden in plain sight. You have the concealed and the clearly visible. So the question is, why is the building shaped like this? And there's three primary reasons. Number one, it's pitched forward to address us, the pedestrians on the street. Number two, I need more square footage on level 5 than I do on level 3. So that kind of naturally creates this inverted trapezoid. But the most interesting reason from my perspective is the Spy Museum is a building on top of an existing building with another building in the middle. So that means there are very specific locations where we can come down and structurally support our building. And our first column line is back here, column line A. So if we're set back, but we want to engage and reach out into public space, it very naturally creates this sloping form. And that is what primarily drove the geometry of the red slopers, the primary structural elements in the building. Here we are in the lobby. What's fascinating to me about the lobby, it is connected to the veil atrium. We all share the same air. So much of what architects do is really define how to keep people safe in the event of an emergency. So what happens if, say, hypothetically, there's a fire that occurs down here? We have to maintain public safety. In doing so, we modeled 3 different types of fires. What if a rack of t-shirts catches on fire? What if there's an old Christmas tree that ignites? What if the James Bond car ignites? Now, we had many conversations about this. There's no gasoline in the James Bond car. It is an artifact. It will not catch on fire, but it's not the gasoline. It's actually the upholstery, the cushions on the seats. That presented the most difficult, challenging fire scenario, smoke scenario. In the event, or if the seats ever caught on fire, it creates a very thick, acrid smoke that, very difficult to combat. So what we had to do is we had to model the path of the smoke and see where it goes and understand how it fills the atrium and how it rises through the building. From there, we had to integrate a series of laser tripwires that are hidden within the facade, and they're specifically located in the return air path. And then once all of these systems are triggered, that sets off the smoke evacuation system to keep us, the occupants, safe. Nobody is dying in my building. Here we are in the veil atrium. This is the crown jewel of the architecture. A disproportionate amount of the energy, budget, and effort went into getting this space just right. It is also the primary circulation path for all museum guests. Everyone will come down these stairs and make their way into the museum store after the primary exhibition. A couple cool stories about the veil glazing. We worked with a very talented group in Germany. There are probably maybe 2 or 3 companies in the entire world that can build something this complicated. I always joke with them like, hey guys, we have German engineered glass. And their response is, no, this is like a Swiss watch. So apparently, even the Germans have a higher tier of engineering. But let me give you an example. So there's a collection of screws here on these threaded rods. A high percentage of them are threaded backwards. What I mean is, everyone knows righty-tighty, lefty-loosey. Well, a lot of them are actually lefty-tighty, righty-loosey. Like, why? What's the point of that? These talented engineers figured out that if they're not reverse threaded, as you're tightening them, they would move the wrong way and they wouldn't be balanced. Another cool thing is over here, this might be my favorite detail in the entire project. Because of the rapid pace of this construction schedule, we had to release the glass for fabrication before any of the steel was on site nor erected. That means no as-built dimensions. That means no ability to make sure the connection points are in space where we expect them to be. Every time the veil system touches the structural system, we needed 3 dimensions of adjustability. So in that detail right there, we have an in-out, we have a left-right, and we have an up-down. Every time the 2 systems collide, they needed that type of adjustability and tolerance, and honestly, we used every inch of it. We're on top of the roof terrace of the International Spy Museum. And without exaggeration, this is one of the best roof terraces in all of DC. And it has to do with the views, the vistas that we have in almost 360 degrees. But there's a secret. You see, Washington, D.C. has a federal height limit. All buildings, for the most part, are limited to 130 feet in height. You know, there's a couple exceptions, but that's the rule. That vertical dimension, 130 feet, is measured from the sidewalk. It just so happens that this location has a fake sidewalk. L'Enfant Plaza, L'Enfant Promenade, has 2 roads. There's Lower 10th Street, and then there's an elevated bridge that is L'Enfant Promenade. Our height limit is measured from the fake sidewalk, and as a result, our building has a 30-foot advantage on anybody else in the city, which gives us unparalleled views. The backside of the building is flat and stark and just butts up directly against the property line. Why do we do that? In the master plan, there is a future proposed development that takes up the center of L'Enfant Plaza. So in the design of the Spy Museum building, we had to be cognizant of the future development. But in doing so, we didn't want to leave just a blank, boring wall. There's a coded message in the articulation of the facade. Can you decipher it?